Welcome to the second video for Math 135 Intro to Stats at CCD. In this video we're going to cover Module 4 Part 2, looking at measures of central tendency. So to start, we're going to look at the three main measures of central tendency, which are going to be the mean, which is also known as the average. We're going to look at the median, or the middle value, and we're going to look at the mode, the most frequent value. Before we get into that, however, we do need to go over some notation that you're going to see for the rest of the semester. The first one is a lowercase n denotes the sample size. So that is how many people did you have in your sample. So if I went around and I took a sample of 10 people, lowercase n would represent 10. Capital N is my population size. So similar to sample size, but now this is for the entire population. So if my population is students at CCD, capital N is roughly 9,000 students, and I could find the exact number for that population size. This next one, XI, that denotes the ith data value. You may also see it with an X and the I kind of subscripted next to it. So what that means is I want you to go look at that data value. So if I put X with a little 4 next to it, that means I want you to go and look at the fourth data value, or we are looking at the fourth data value. This next one is a funky looking E, that is sigma. That means you're going to take the sum. Okay, so the sigma next to an X means you're going to sum all the X values, or add up all of the X values. Okay, and those X values are your data values. So that's like X1, X2, the number in that position. So you're going to sum up all your data. This next one is an X with a bar over it. That's the notation for the sample mean. This is going to be a very important symbol. We're going to see it a lot in this class. And then finally, the last one here is kind of a funky looking M, or a funky looking U. This is another Greek symbol. It is mu, and that means the population mean. Another very important symbol. Okay, a little bit of a rule of thumb with these symbols. If you have a value that is a normal letter that we're used to seeing every day, like this X, okay, that means that this is coming from a sample. If it's a Greek letter, like the mu is, most likely it's going to be coming from a population. There's only one instance where that rule is broken, and that's not going to happen until we get into Unit 3. So if it's a normal letter, that means it's a sample. If it's a Greek letter, it's a population. So we're going to start by looking at an example of calculating the mean. So right here I have a table of exam scores for a class of 6 students enrolled in an Intro to Stats course. So it's not the full class, it's just 6 students that I pulled from this class. So we're going to go and we're going to find the mean for this test for these 6 students. So we're going to go find the average for these 6 students. So using the proper notation, I have my X bar, and that's going to equal, so I'm going to add up all of these numbers. So 69 plus 72 plus 81 plus 83 plus 72 plus 91. And then I'm going to divide it by the number of observations that I have. So I have 6 data values here. I have 6 observations. So I'm going to divide by 6. I'll give you guys a second to do that. And you should get 78. So that means the average score for these 6 students is a 78, almost a B. Not quite there, but almost. So now we're going to imagine that there was a 7th student in the class who missed the exam and received a 0. So I want to see how the mean is affected if I include that student's score when I calculate the mean. So now this time what I'm going to do to calculate the mean, I have my X bar. I'm going to add up all of these numbers again, plus 72, plus 81, plus 72. but now I'm going to include that score of a 0 on the end. So now instead of dividing by 6, I'm dividing by 7, because now I'm looking at 7 students. And the average for these 7 students is a 66.85. Okay, let me fix that real quick. Sorry, guys. My pen is not working. There we go. 8571. Okay, so I included that student that got a 0, and now we see what happened to that score. So what did happen? So when I only had the 6 students, we had an average of 78. But now that I've included this student who got a 0, the mean dropped all the way down to a 66. So we saw a significant decrease in the mean. Okay, the mean went down a lot. We were at almost a B, now we're at a pretty solid D. Okay, whole letter grade decrease just by including that one student with a 0. That's going to be very important to remember. So here are 2 examples of how to calculate the mean. Add up all of the numbers and divide by the total number of numbers that you've added. So if you add 20 numbers together, then you should be dividing by 20 when you're finding the mean. All right, now we're going to look at how to find the median. So a couple of steps for finding the median. The first step, the most important step, is to arrange the data in ascending order. Just going to put some exclamation points right there. Okay, if you do not put your data in ascending order first, everything that you do after that's going to be wrong. It has to be in ascending order. So then we're going to look at how many observations we have. If we have an odd number of observations, so now I'm down here looking at an odd number of observations, then the median is the data value exactly in the middle, and we can find that position by taking the sample size, adding 1 to it, and then dividing by 2. If, however, the number of observations is even, then the median is going to be the mean of the 2 middle observations, because we're not going to be able to find a single number in our data set that'll split our data in half. So we're going to have to find the mean of the 2 middle observations. So to do that, we're going to find the n over 2 position for the first number and the n over 2 plus 1 position to get that second number. So we're going to look at examples of how to do both of these. And we're actually going to start with the even number of observations. So this is our data set from before, but it's just the 6 students. We don't have that 7th student in here right now. So we're going to go and find the median of these 6 students. So the first step, the most important step, put your data in order. So 69, 72, 72, 81, 83, 91. And there is my data set in order. So now I'm going to use the equations n over 2 and n over 2 plus 1 to find the position and value of the median. So to do this, I need to take n over 2, so n is 6. Ooh, it didn't actually turn on. And divide that by 2, which is going to give me 3. And then 6 over 2 plus 1. So that's going to be 6 over 2 is 3 plus 1 is 4. So this tells me that I need to go find the 3rd position and the 4th position of my arranged data. So 69 is in the 1st position, 72 is in the 2nd, the second 72 is in the 3rd, 81 is in the 4th, 83 is in the 5th, and 91 is in the 6th position. So I'm interested in the 3rd and the 4th position. So I'm interested in these numbers here. Oop. Let's try that again. There we go. So I'm interested in 72 and 81. So what I'm going to do is I'm going to add those 2 numbers up and divide by 2. And that's going to tell me what the middle of those 2 numbers are. And that's going to be my median. So 72 plus 81 divided by 2, the mean of these two numbers. And that's going to be 76.5. And that is my median. All right. So that is finding the median if you have an even number of data values. So now we're going to go on, we're going to look at how to find the median if you have an odd number of data values. This one's a little bit easier because we don't have to do this last step of adding the two numbers together and dividing by 2. We're going to find just a single number for our median. So the first step, just like before, we need to put the data in ascending order. So now we're looking at all 7 students. So our smallest value now is 0, and then the rest of it is the same as it was before. 69, 72, 72, 81, 83, 91. Yes, sorry, I thought I missed one. Okay, so now we're going to use the equation n over 1 plus 2 to find the position of our median. So our n in this case now is 7 plus 1, that's going to be 8. Then divide it by 2, 8 over 2 is 4. So I need to go find the number that's in the 4th position. So 1, 2, 3, 4. 72 is in the 4th position. So my median is equal to 72. A lot easier to find the median with an odd number of data values. Okay, so now let's look, because we looked at what happened with the mean. So let's look at what happened with the median when we added in that 7th student. So the median when we had just the 6 students was 76.5, but now our median with all 7 students is 72. So we did see a little bit of a decrease again adding in that 7th student, but it wasn't nearly as drastic of a decrease as we did with as we saw with the mean. Okay, we were at a C here and we're still at a C down here. Whereas remember before we were at a C, almost a B, and that dropped us all the way down to a D for the mean. So the important thing to remember for this is that the mean is going to be affected by extreme values. So an extreme value is a value that's a lot lower than the rest of the data, or a number that's a lot higher than the rest of the data. Okay, it could also be called an outlier. We're going to look at how to actually calculate for outliers here in a couple of sections. But right now we're just going to call them extreme values. So the mean will be affected by an extreme value, but the median is not going to be affected by those extreme values, at least not as much. It definitely was affected a little bit, but we didn't see nearly as large of a decrease in our median as we did in our mean. So what we're going to look at now is the shapes of the distributions and how the mean and the median appear on those different shapes. So we're going to look at a symmetric distribution first. Symmetric distribution is going to be like our bell-shaped distribution or our uniform distribution. So I'm going to do the bell shape because we're going to see him a lot more than we are the uniform distribution. And it's symmetric because if I draw a line directly down the center like this, it cuts it in half, and what's happening to the left of this purple line is also happening to the right. It's like a mirror effect. And this purple line that I drew right in the middle, this is actually where my mean and my median are going to fall on a symmetric distribution. They're going to be right in the middle. And they could be a little bit different numbers, but they're going to be pretty much the same. Okay, now we're going to look at a skewed left distribution. So remember, the skew is always what side is the tail on. So the tail is going to be on the left, and then we're going to have our peak. Most of our data is going to be over here on the right. Okay, that's not what I wanted to do. There we go. All right, so now we're going to take a look here. So our median is always going to be in the middle because our median's not going to be affected. So our median, I'm going to put it roughly here. It's not exact, okay, just kind of eyeballing it right now. So that's where our median's going to fall in a skewed left distribution. But the mean is going to be affected by this tail. So this is just like what we saw in the example above with the test score data. We have an extremely low number that's causing this skewed left distribution, and he ended up pulling our mean down. Maybe not always that much. Okay, but the important thing is our mean is quite a bit less than our median in a skewed left distribution. And then finally, skewed right. Remember, most of our data is over here on the left, And we've got a long tail coming off to the right. And for this one, our mean and our median. So median's still going to be in the middle, about here. And then our mean is going to get pulled towards the tail because he's going to be pulled up from these extreme values. You're going to have a much higher mean than median if your data is skewed right. So those are the three shapes and what you can see happen with the mean and the median. So then finally what we're going to look at is how to determine the mode from a data set. So the mode is the outcome that occurs the most. So in this first example here, we're going to find the mode. So we're going to look at which of these numbers occurs more than the rest. Well, for this first one, it's not too hard. It's 0. There's a lot more zeros than there are any other data value. So next example, find the mode of the data set from example 1. So that's our test score data. So we're going to go all the way back up to example 1. Oop, I passed it. Here it is. And we're going to find the mode of this data set here. So 69, 72, 81, 83, 72, 91. Well, the only data value that repeats itself is 72. So 72 is going to be the mode for this data set. You can have one mode. You can have 0 modes. If you don't have any number repeat itself, then you don't have a mode. You can also have more than one mode. Just remember, it's whatever occurs the most. So if you have a data set where 2 numbers repeat themselves 5 times and another number repeats itself 4 times, that number that repeats itself only 4 times is not the mode. It's just the numbers that repeat themselves 5 times. That's just an example. Okay, so if you have 2 modes, then your data set is called bimodal. Bi means 2, and then mode. If your data set has 3 or more modes, then we call that multimodal. Okay, and then the last thing with mode is it is the only measure of central tendency we can find for qualitative or categorical data. We can't add words together and we can't order words because I might say that these should be ordered alphabetically, but someone else might look at these and say, oh no, these are body parts, they should be ordered head to toe. Ordering them is subjective, so the only thing we can find with qualitative data for a measure of central tendency is the mode. So this is the data set from the first set of notes where we were looking at a physical therapist's office and the injuries that she saw on a given day. So if you recall from those notes, back injuries happened 12 times that day and there was nothing that occurred more. So in this case, back is going to be our mode. And that's it. So just going back up to the top for some review. So we looked at how to find the mean, add up all the data values, and divide by the number of observations. Median is the middle data value, and the way you calculate that depends on whether you have an even or odd number of observations. And the mode, the most frequent observation in your data set. And it's the only one that you can find for qualitative data. So that's it for Module 4, Part 2. See you next time.